I have to circle back a little bit to explain or to talk about where you're heading, Eric. I see an incredible opportunity in these technologies to be able to sift through the entire history of the architectural discipline in an instant. This is something we couldn't do before as architects. So I think it's an incredible possibility that if you have thousands and thousands of examples of what columns can be, what openings can be, what ceiling solutions we have, what spatial, like which plan solutions we have done as architects in the last 2000 years. We are the only discipline currently probably operating who has such an enormous repository of knowledge just lying out there. Yeah. If you harness that and you really put that in a database and you label it correctly, I'm not saying we're there yet, but we're going to be there very soon. You can basically start to combine your own sensibility as designer with the disciplinary knowledge that exists. Yeah. And by doing so, you can maybe come up with higher quality architectural solutions that you can do on your own as a designer alone. Yeah. So basically, instead of you putting your nose into hundreds and thousands of books and trying to make sense out of it, we are using a neural network that is faster, much faster than we ever could in finding interesting solutions in architecture for a problem we have. And this is only the beginning. Like there's so many other possibilities in that area. Like I'm talking about from totally pragmatic, like just checking whether your plan actually is correct towards code, to totally experimental possibilities. That's what makes me so excited about
that. Is that
Pablo.
An ambition?
Yes, Pablo.
How are you? No, I'm glad that I joined here because, you know, I've been working with 3D scanning since 2011, 2012. And I'm glad that you're addressing it because with Andrew Saunders, you know, when we were in Rome scanning, 3D scanning the Baroque churches, you know, I actually work with Sapienza University for many years with the Restoro department. And, you know, the problem that you're hitting, and it's a problem that we were not able to resolve between semantics and point cloud relative to RGB value and using neural networks. We have been trying that for many years. And it was the results that we had from a scientific point of view were irrelevant because, you know, we're trying to kind of compete with scientists at the same time so that our research has some external, not only internal validation, but also to think about how we can contribute to other disciplines. And the problem of the relationship between semantics in terms of the history of architecture, right? That's one issue. Like how do you train the neural networks to recognize certain architectural values? That's already a problem because you enter into bias, right? Not only you have to realize whether it is working or not working, but also the bias, and that's the problem that we have with the Baroque, because in the Baroque, that bias disappears because there is a blurring on purpose between figure and background. So then in that sense, the neural network will never be able to get to that level unless you are, and which is what the mathematicians are dealing with. How do you get rid of just entering the semantic reading and then be able to get rid of it at the same time? It's like really, it's almost like a contradiction, you know, because you have to train for the convention, but at the same time, you want to be able to also recognize the non-conventional ones. And that's when the problem starts in with the bias, no bias. On top of that, the point cloud is only meaningful from a scientific point of view relative to RG value and GPS position. That's it. The semantics are totally irrelevant. So then there are like 3 or 4 layers of problems that I was not able to figure it out yet because I don't know. I think also what you're saying that in terms of the history of architecture, how you deal with that and how you think about it critically. That's what we actually are publishing many articles about it. And it is also an issue in itself. So I'm glad that you're, in a way, what's interesting is that you're dealing with the problem. I'm not sure at a certain point whether, we're spending a lot of years, right? And perhaps we may not be able to do much significant. And that's what is happening to us, at least with the point clouds, that They literally, and also we did automated scanning, you know, like by actually retrieving information from different point of views, packing it back together. We did an amazing study in 2017 at Cooper, retrieving information automatically, but using point clouds. But then the semantics always comes back at the level of the image versus the syntax, because the syntax, what you want to arrive to is a syntax. And the problem is that if you have semantics, which is image-based, then you have the point cloud that is the one point and the other, there's no relationship. It's just color and position. And then you want to arrive to the syntax. That's the challenge in a way. But I don't think anybody was able to figure that out yet in a cohesive, interesting way. And I think that that's the challenge. So I'm happy that I came into this discussion, because in the other review that you had before, I didn't see this. So I think it's a very interesting area of research, and I don't know the solution. And I think it's a very interesting territory to be at today, you know, in terms of what you do with that, how you design with that. Obviously, it's big data. There is big machine learning involved, right? There are many interesting levels of issues, but I'm not sure. Also, in terms of what Eric is saying in terms of design, I think it's also irrelevant. Like, you have to be aware of what's happening at the philosophical level in other disciplines, right? Design is becoming a little bit a troglodyte word, because if you say design, you're operating from an intuitive point of view, and from a data point of view, it's like nobody cares, right? So it's an interesting, there is an interesting problem. I think we need to address them from a theoretical point of view, from a historical point of view, and the current revolution relative to data science, which is to totally eliminate those categories that we are used to learn, right? So it's a very different type of problem. So I think in a way.
That's a great statement, Pablo. Thank you very much. Also, maybe to add to one thing to this is, I mentioned at the beginning that what this seminar is, or this seminar builds up on institutional knowledge that we have gathered now in the last couple of years working on this problem. So every semester, of course, we're trying to make more progress and talking about specific problems that come along. And for example, we didn't discuss so much semantic information last year. We didn't discuss so much bias last year, but this year we're discussing that because we discover things on the way that we need to talk about and solve. And the thing about bias, for example, is that, and we read a lot about bias this semester, it's also, you can actually also use it to your advantage. It's not only a disadvantage, yeah? So one example, this summer I trained a database which was based on my own 3D models, like what did I generated and I made, yeah. So I could totally say, yes, this is my models, it's my sensibility, is what I design, and I have like 1,500 models, and all of them had also specific labeling, like how do they perform structurally, how do they perform in terms of material consumption, how aesthetically pleasing are they to me, which is of course a purely, it's totally biased towards me, like the designer. But the funny thing is that that database allowed me then to generate new models, and those models for me were successful because I could say, yes, I could design something like that. So it's actually starting to replicate my own sensibility. Yeah. But then again, there's this whole discussion about now, who's the author? Am I the author because I created the database? Or is the author the neural network? Or is the author the person who wrote the code for the neural network? Yeah. So there's always these things happening.
What you see, to me, that's why it's important. The current boundary now in not only in data science related to bias, but in terms of machine learning, AI, kind of intuitive AI, whatever you want to call it, is the how can you make sure that there is a system of reference in which you realize first what's going on, obviously, to understand more critically what's going on, and to be able to actually go beyond the system of reference. And it's very difficult because when you have all these algorithms running in parallel, they are correlational, right? And they are all of, you know, it's like obviously by hand or by logical system, you will never get there. You know, it would take you 100 years, 200 years to analyze one of them, right? And the point is not there, but how do we, as humans, right, are able to come up with a way of using these systems in a more critical way, so that, or maybe, eventually, of course, we're disappearing, but what do we do in relationship to that? And how do we make sure that, because, you can do a neural network that has like, I don't know, 1,000 layers versus one that has 3, and perhaps the one that has 3 is more, robust than on at the engine level. You have to somehow be able to make sure that there is a system of validation, so that there is something in the end product that can be able to measure what's really happening at the coding level and at the result level. Because otherwise, I'm sure you're aware of the MIT, they are saying that we lost 10 years of research because a lot of things are totally useless, because they realize that at a certain point, it's totally irrelevant what happened with the result, because the several layers are actually tending in so different odd directions that then when you do the systematization and the in terms of the data set, in terms of the statistics, right? Because the only way to measure this is through statistics. And when you realize what kind of curve you're working on and so on. But when you realize that perhaps it's totally irrelevant, I mean, how do you measure? What is the system of validation, and how do you make sure that what's happening is relevant or not? And that's, I think, that the next barrier, right?
Yeah, I'm not sure we are there yet, but I think we're gonna get there soon. One of the things why I'm not only fascinated by the opportunities given by these new like neural networks or AI in general, but I'm also aware of the problem that if we as architects do not tackle the problem now, aware of what it does and how it works, somebody else will do it for us. Yeah. And then you don't want to be in the role of the architect, because they're just gonna, this is a fantastic tool for developers, for example. Yeah. So they will just pick it up and use it. And if we as architects are not informed how to use it and how to resist that, yeah, then we're gonna be made irrelevant. So that's why I think it's important to be aware of this.
By the way, I totally agree, but I would argue that has been happening for a while, not even before AI.
That's true.
And that's the success of corporations.
Well, where we are from, in Buenos Aires, that won. Architecture disappeared, and the real estate completely won.
I mean,
it's amazing.
But in the US, Eric, it's even worse, because in the US, I mean, at least the buildings in New York City, the architect is given the core and shell, and you just decorate the curtain wall, right? In terms of what Matias is saying, has been happening. I'm glad that we're raising that up, because I'm developing a lecture series for next semester at NYIT, and we're dealing with what are the parameters, why architects are always behind in a way, right? And why is it that, and I agree, I think that, if you see what actually students of mine, by the way, are becoming very rich and millionaires. There are many of them are in Silicon Valley, and the things that they are doing is a little scary even for me, because I'm not getting any money, right? I'm not getting a cut, right? But in a way, that's the objective, of course, in Silicon Valley, to get rid of all the middle people. And they are actually one of the groups is very famous. Are doing the Amazon houses. Architecture is not so interesting, but the system that they have is the real architecture, as you're saying, Matias. And yes, they are taking out thousands of practices, and they were able to raise $10 million. They're in the Forbes magazine, right? So I think that that's what we are aiming for, is to understand those architecture at that level. That's what I called architecture of information, right? In 2010, when you guys were in Acadia, right? Remember what happened in Acadia? I remember that the architects there, they were upset at me. They were almost throwing me tomatoes, you, Eric, included, because
I would throw tomatoes at you any day.
Well, exactly, because you were saying, I mean, some people were saying that, well, the role of the architect. And I was saying that authorship was problematized because the actual real architects are the ones that are doing the software more than us. And that's exactly what, Matias, you're pointing out, that because of that replacement, right? If you don't work at the same logical, topological level, at the same level of information, you're out, because you're going to end up being the decorator of a system that is already given to you. Yeah. That's when I become critical of the word design. I'm familiar with what you guys are doing, and I know that it's difficult, so it takes time. So I appreciate that. What you know, from a reviewer point of view, I guess Eric's question is, okay, so what do you do with that? But I know that it's like a learning curve that is a little steep. So, so I think that it's very interesting what you're showing. Perhaps at each stage, something that I do in my studio is at each stage, maybe there could be a more architectural moment in which each step of the different combinations of different tools and algorithms gives you one type of problem in a way. So that then you don't have to wait until the end, until seeing if you can grab all of this together, because it's going to be very difficult. So I'm just wondering about the methodology, Matias, because I know what I like is that you're very ambitious, like me. I am very ambitious, right? At the same time, you know, we have the time, I mean, it drives me crazy, and you probably have the same problem. Like, you know, the time of the studio until you train this, and then the students change, and, you know, you have to start over again. So I know what the type of difficulty you're going through. And the question is, how can one give like methodologically, right? Like jump back and forth, so that and also something that I did at Cooper after years of getting frustrated that the students were not at the level that I wanted them to be computationally, is that in a way you don't learn the tool and then you apply it, but you do the exercise while learning the technology, so that then you don't separate them in a way, right?
Yeah, I think I have to add something here for the jurors so they understand the frame in the studio a little bit better. So we have help from the robotics department and from the Department of Computer Science here at the university. So there is Alexandra Carlson. She is a PhD student at robotics who set up the whole coding platform for what we're doing. It's all streamlined so that, or at least some of the techniques are already streamlined so they can be used really straightforward instead of having to code everything. Oh, okay. And then we have Danish Sayed and Manas Jyoti Buragohain, who both basically serve as assistants. They're both graduate students at computer science. They're coding wizards, yeah. And they help us out when there is coding problems and so on. And what we are encouraging students to do is to go into GitHub and find the one coding stream they're interested into applying in their project. And then in collaboration with Danish and Manas, they translate that to our paperspace workflow. Yeah. So because otherwise students would have to become like wizard coders in no time. Yeah. And that is really a bit too steep, I think, for 2 semesters. And I have also to say that I'm really trying hard to build up institutional knowledge, which means that every semester students are building up their databases, the ways we're working on, and then the next incoming students can work with this too, which means that, you know, the more students work with it, of course, the more the knowledge base grows. Yeah.
We are doing the same in NYIT. Actually, our dean is amazing in that sense, because Maria Pervelini understands exactly what you're talking about, right? It's very important from the administration point of view. Also, the president, by the way. Our president is very trained in computational thinking. So the entire institution has to be lined up. So I can see that you have you're working with all the different departments. That's actually great. It's difficult to get to an institution that works like that. So that's nice to hear that.
And I also have to say, it takes two to tango, right?
Yeah.
So it's not only me going there. Actually, it's mutually beneficial for both of us. They get knowledge from us, we get knowledge from them. So we recognize the value of interdisciplinary work.
By the way, if we don't, and I also we need to think how we can collaborate between the different institutions, because if we don't do that, by the way, we're going to be gone in 5 to 10 years. Eh?
I completely agree. Yeah, we're going to talk about this in private, okay? Like,
exactly.
I was asking if we could involve Daniel in the question, because to me this he's been possibly the most dedicated to this kind of work. And in his experiences and his observations of what you get at when you work intently and irreducibly in this manner, how far along are you in regards to understanding that there is an irreducible effect? There is a way of producing architectural or spatial or even artistic effects that I'm very interested in related to architecture that are certainly almost getting close to the notion of irreducible effect of working with AI. Does that question make any sense? In relation to how they spoke about this, slide that they wanted, the students wanted to make sure that they're going to be working in a way that cannot be achieved with any other process of working. So I'm very interested in what would that be, and I think you're the closest.
Yeah, for me that will mean that we have to connect like every single design decision in a way to try to create a sort of process, AI process that in a way mimics that and learns more than we normally will be able to learn. Because otherwise, what I think is happening is like we just give one AI that addresses one very broad, in a way, topic of design, then we connect it with another broad topic, and mostly what we are doing with that, we are really like saying that we are not forcing, actually, we are not biasing the design with our own preferences, but actually we do, yeah. So in the end, we still end up with something that actually is familiar to us, yeah. So in the end, we still end up with something that is really, we already see that, it's just that it's a bit more strange that we normally are familiar with it, yeah. But I think in order to get to a sort of result that it's really like something that you never think of it, yeah, then I think you have to be very truthful to the idea of really designing the DNA of the project and just work at that level and that let it manifest from there on, yeah. I think that would be in a way a sort of process here. And I think here it's a very complex in a way problem, because I think only once you start to go there in that kind of field, you start to realize actually how crazy the brain is, you know, like how because for us, like this kind of like tiny processes that for an AI, we have to develop entire data sets. For us, it's very easy just in a second just to realize, okay, that's this is this kind of moment, this is that kind of moment, yeah. And when you realize in a way how many tiny steps actually we have to go through as designers, it's amazing, yeah. And I think then it's also a question when we look at this kind of scanning things, like for me, it's also a question of what kind of information is relevant and at what scale of design is actually that information relevant. Because it might be that at a certain scale, it's relevant to see furniture, but at the other scale, it's not relevant. And the concept in a way is not going to change at all. Yeah, on contrary, probably it's going to just create some absurdities if you have also furniture included in that equation. Yeah, so yeah, my take will be, and this is where I'm working on, like trying to build up every single step that you have actually in design to build it, having a sort of neural network or something, and then build up something like that, and then maybe you can say that really you have some architecture that it's something that you never seen.
There is also another aspect to what Daniel was just describing, which is basically you have two sets of problems here. Like, I mean, you have on the one side the ontological problem of how these things is becoming, how it's actually turning into something specific, right? And then you have the epistemological problem, like what did you learn out of the process? Like, does it really inform your design in some way, shape or form that makes you make progress as a designer? Because what we're doing here, we're not saying the AI is the designer. That's not the point. We're not even interested into that, actually, right? I mean, it's the idea of how this new tool that is coming into existence as we speak can inform architecture in a variety of different ways. And funny enough, I have to say that aesthetically speaking, there is so much going on with these possibilities, which is absolutely fantastic. Just think of these point clouds that we've seen today several times. And Pablo also was working with point clouds. think about the aesthetics that point clouds actually generate. It has this very ephemeral, translucent quality to it. It's almost like an X-ray of the building. You do not recognize it anymore, mass and void. It's all either or. Yeah, so there's like a whole set of really important architectural questions that those things actually bring into the foreground. The neural network stuff that Daniel is doing. And by the way, I think it's definitely creating something like a style, because everyone is using the same codes. The things look kind of similar, right? I mean, the results are exchangeable. No matter if an artist is using StyleGAN to do based on the database of 500 years of paintings, or architects are using photographs of a specific architectural office, the way how the generative adversarial network is working for those is always generating imagery that is somehow related. It's a family of aesthetical conditions that is currently emerging, which I think is super interesting because it's very different to what we know still now as architects. I have made the argument that this is the first genuinely 21st century design technique in architecture. Because everything else we've done in computational design before in the 21st century was already invented in the 20th century. So there's like a whole plethora of possibilities there.
But Matias, that's what I call the digital signifier, that the point cloud as an aesthetic problem, right? In a way, I totally agree. I wrote an article, I don't know if I share it with you, but I wrote an article from Perspective to Big Data that actually it's an old article from 2013, 15, when we started working on point cloud. It's exactly the issue that the media is the message, right? Since 1970s. And that's what when people, I think, misunderstand what I mean by authorship. And I think it's exactly the issue that the authorship nowadays is at the meta level. And that's why we are displaced as authors in terms of design, because the system is ruling over whatever semantics. I mean, whatever narrative, semantic system, discipline doesn't really matter, because the computational system is much more robust and imposes ideology, aesthetics, right? All these issues. So I'm happy that we are pointing those out, because that's, to me, where the real challenge is today, the barrier. And if we don't, and my argument is that if we don't invent one, I think that's where the problem is, that there is no real authorship. And I know that it's problematic to say that, but at a certain point, what is your role in all this? What is our role? I'm not blaming anybody. Eric got a little bit sensitive, but I'm not blaming anybody about like who's doing design, who's not doing. I'm just
but I think
trying to
what's
raise
interesting,
the issue. You know?
Sorry to overstep, but I think that what I wanted to go back to something that Matias was saying about the epistemological aspect of the work, which I find a lot of value in, because given the stressing of the question of authorship, which one can say modern art has been dealing with that question for about 100 years.
Yeah, even barely, before, right? Even Alberti, and then, you know, like
in art specifically, in a self-conscious way, where also there's been work written about the particular problem, one could say at least 100 years.
But no, Alberti 500.
That's why I'm
Alberti
the thing
says
is
that the architect is the author, right? And then he broke everything.
In regards to that, what I'm trying to come out is that I think that the fact that you could somehow organize the way in which you intend to work for any given project in a way that all that you're doing is conscious of certain kind of cycles and protocols of time operations that you're going to go through and the project is going to go through with you. What you're doing is you're sort of tooling the ways in which you want to affect yourself as a designer. Sort of, in a way, you're trying to set up a process that is going to have a certain impact in the ways in which you make relational assertions during the process. I think, to me, that's possibly the most interesting thing, where you are designing the human. You know,
you're saying that it's transformative. That I agree.
Yeah,
that, it transforms
that I think
yourself.
is the most. There is that potential that you could harness.
No, of course, and I think that in a way that's a headache that the students in the School of Architecture go through. It's a kind of if you have a good professor it changes your brain and it's uncomfortable, right? It's like a headache. And that's the difference between a good professor and a bad professor, right? Like somebody that cares, like Matias, Eric, right, Daniel, they all care about what they're doing. And then, but it's difficult and you complain, but then it's the only thing that perhaps you're going to remember in 20 years from now, right? Because it's transformative, as Eric is saying. In a way, that also the issue of design, like the signifier, right? The deconstruction of the signifier. And when, the article that I'm referring to about digital signifiers is that it's very difficult to deconstruct the signifier at the computational level. And the hackers in the 1970s, that's what I think an aspect that we are forgetting about. Computational knowledge in the 1970s was much more radical than what it is today. Today, I think computation is too much. My students are actually doing very well money-wise, but I feel sorry for them because they are really missing the avant-garde, because everything is measured in terms of money gain, right? Like whether you make $1 billion in your startup, right? That's a measurement of success. And in the 1970s, the radical ideas about computation, for instance, blockchain, right, was a radical idea about, I don't think there are not that many people working at that radical level. And I think it has to do with what, Eric, you're saying, that people are just using the tools, which is my criticism of authorship, right? Like tooling versus a transformative aspect of, if you want, of the architecture of computation, which would be that not only you change, but actually you overcome the tooling and you create your own set of systems for referring to reality. That's, I think, that's my problem of how we are, and I include myself, right? Because it's very difficult. There's a lot of history and theory. You have a lot of information to take. But there are not that many architects working at this level. So I'm always happy to share reviews. And we did one in the summer, we had a similar conversation about what the real role of the architect is. And the Digital Futures in that sense was an interesting platform because there were a lot of different voices, right? There was a lot of attention in terms of big data and AI, but I'm not sure if the curators were that radical in terms of addressing theoretically and intellectually what it means. I know that there is a lot of new technology addressing the new technology, but I'm not sure at what level, philosophically speaking, right? Either thinking that philosophy is useless, right? But at the philosophy of computation or computational thinking, if we are being accurate in terms of addressing these issues.
I think that's a very challenging thing because to get to a level where actually you control the tooling and not the other way around, I think it's very challenging also for us that we are doing this for many years. It's very, very hard. So for me, this is where I have also the challenges because I'm trying to apply it completely, or I'm trying to be very careful with what type of algorithm you apply where, because I don't want to just apply a GAN just for the sake of applying GAN, yeah, because there are other algorithms maybe that are proper for a specific task that I'm addressing, yeah. And then the design process in itself, it's extremely complex. So suddenly you end up maybe with a design process that requires, I don't know, 10, 20 different algorithms to really make it novel or, make it very interesting. And you have to, in a way, master then all those kind of algorithms and be able to really control them so that they output what you're looking for or, what's the scope of the project, yeah. But I think in some cases, you can also look at all these processes that we are engaging with, and also when you look at breaking design process in steps, you can also try to look at as an opportunity to try to see things differently. Anil said, I think he was saying something like, to learn to be creative is to learn to perceive things differently. And many times, of course, this kind of computation can help us in a way to think or to perceive certain things differently. But I think it's a matter of how we gain control of that and how we can actually explore that instead of just having a tool that is actually controlling the aesthetics and so on.
I like that because it kind of resonates a lot with this idea of deterritorialization, or the idea of again, détournement or estrangement. So I know, Matias, you probably want to move to the next, but I like as a kind of picking up what different people are saying. I want to retain from this project this notion that that with this kind of technology and this kind of standard, this kind of processes, you can aspire to ultimately redesign yourself, like design the architect, setting up the feedback process that's going to affect how you're going to be affected as a non-biased but biased person who's setting up the tactics of a game that doesn't have a strategy yet. When I find that tension to be extremely provocative, and I'm really interested. So I want to say that. The part that I'm not so excited, that's what I have to say, Matias. I know we should expect nothing, and that makes for the best possible dates when you have a date. But that there was some anticipation on my part, that where you said there would be a parallel between the analysis of art practices and AI and architectural parts. Where is that? Or is this art?
I think that was a little bit misleading. So because this was part of the seminar work. So basically, yes. I made lectures about art and AI.
Oh, okay. I wanted to, damn it. How can I be on those lectures?
Yeah, they're all online on my YouTube channel.
Excellent. I'll catch up.
So there's one about art and AI. There's one about music and AI. And I think I'm going to upload soon one about literature in AI, because there's a lot going on there.
Nice.
And we had these discussions, and I mean, I'm inviting also now more artists and musicians to be part of this conversation. So in next week, I think I have a conversation with the guys from DataBots. I don't know if you know these guys.
No.
This is a completely new style of music called neural music. And they have a 24/7 radio station, AI radio station, that is only playing AI generated death metal.
Oh, I saw you put something about it. Yeah.
Yes.
Intriguing. But I think that, to broaden the spectrum so that we don't look at everything just with our architectural glasses, but rather, understand creation in a much more raw way, with a different kind of drive than the architectural drive. Is important.
So I think here this project, like maybe not directly, but somehow raises this idea of stigmergy, which is, for me, it's, I mean, I did a lot of work in that part of stigmergy, and I find it super interesting when it comes to this kind of like factor of having to forget something. Yeah. So you have those traces that, you have a system that lays like traces behind, and those traces somehow they evaporate. Yeah. And the fact that those traces are not there permanent, like forever, that allows, for the system to find better and better solutions sometimes, or to adapt to new conditions in the environment. Yeah. And I think this one connects also with I think we kept on having this kind of discussion about AI, like how is AI adapting to completely new new input information. Like I think at one point there was a discussion with the floor plans. I think Sandra was mentioning that at one point. Like right now, the way we organize floor plans, like 100 years ago, it's completely different than the way we organize plans now, and mostly has to do with certain ways how we perceive our society, that the space has to be organized. And I think that's an interesting, like this kind of parallel, like the forgetting as part of learning in a way, or part of growing. So I'm just curious, like, in AI, how can we have this kind of systems to start to forget some things, therefore, in a way, progressing and learning even more or something, I don't know, what's your opinions about this?
Yeah, I remember reading something about generative adversarial networks that can forget, but it must have been really today or yesterday that I read about it. And I forgot it already. Let's see. That shows how our neural networks in our brains actually really forget very quickly.
Yeah.
You know, one of the interesting things, I'm not sure if it is related to what we are discussing, but one of the interesting things about these theses, now, sorry, I apologize again, I was reading them as projects.
Don't worry.
So now I feel that there is more interesting path ahead. And in this case, I think it's interesting, the problem of additive logic, right? Relative to a generic structure. And I also have been interested in that for a while, and I know other architects are also interested in that. To me, what it comes to the end, especially dealing with CA, that is mathematically is like an incredible system, right? It's like very, you know, like something that, that I'm interested in, those logical systems that somehow through the past of technology, they were not able to be overcome because there's an intrinsic logical problem that to me is what matters. So here is the site-based problem that CA presents, which is to me one of the most fantastic, interesting issues that accumulative logic would present. That, in other words, that and it's not just collecting boxes. And I think that's where the architects have problems interpreting CA to architecture. I just did every year I try to repeat CA. I always have a group of students because I'm interested in the mathematical concept and the philosophy of CA. Like Carl Chu, we had a conversation for many years, series of architects working with CA. But you know, if you think about the site-based problem is the issue here, which is not accumulating boxes. It's very different. You have to be very aware that I know that architects, we think about modules and we put them together, but that's not the point. The point is to create and I know that at the AEA, they have been working a lot with clustering. I am a little critical of that way of working. I think that the overruling thesis here will be how you can come up with another structural system like the ants literally do, that the ants don't just accumulate things. They create other structures out of accumulating things, which is a different concept than putting boxes together. And I think that if you could develop a thesis that somehow would make sense on the real transformative aspect of accumulative logic and even evolutionary logic, right? Because at a certain point, the system evolves and there's a certain emergence condition, and then you have to be aware of where that transformation happens. Otherwise, you just let the system run and you miss the opportunity. That's why you have to learn all the rule sets. You need to know what has been written about it. Otherwise, you miss it. You know, like just, and that's something that typically happens. And I think in Matias' case, Matias is more precise than other architects working with computation. And Daniel, I don't know you, but I just saw a little bit of what you're doing. It seems very interesting. And there are not that many people, to be honest, that they do that. Because I think architects, we get trapped by the visual logic right away. And then we miss the opportunity for logical systems to become other things that we are not expecting to become. And the emergent logic comes in exactly there, at the crossing of understanding that there is an opportunity for something that you not expected and can grow into something else. And I think that because you have time, now I talk differently about the project. I think that here you have a very interesting project. There has been a lot of architects that dealt with this. Just be aware and try to understand, to me, at the deepest level, what is it about emergent systems that eventually would be able to go beyond accumulating boxes. Because and also voxelation, you know, voxels, the way architects are also working with voxels, to me is also problematic, in the sense that the cell in itself or the 3D container doesn't change, right? And I've been trying to struggle with that. I did not find a solution. So I'm critical, the typical criticality, right? I'm critical, but I myself, you know, I know I didn't come up with a solution, right? But at least to me, it's important to understand what you're struggling against. Otherwise, the thesis is not going to become relevant. You know what I mean? It's just going to be one more. And use the opportunity to have a professor like Matias to push yourself and to go beyond. And I think that, by the way, the methodology of the studio, you're looking at bibliography, you're looking at algorithms developed, so you went to Acadia, is very robust in terms of the methodology. And I think that in that sense, you are more prepared than other studios than just addressing the thing individually. And I hope that I'm very interested. I want to see it next semester to see what you come up with, but try to be critical about what other people did. And I think that's why you have this collection of images here, because that's the objective. So just be aware of that, you know.
Maybe to add to this, in the computer science department of the university here, there are basically two specific schools of thinking in terms of how to apply artificial intelligence in 3D. And one of those is with voxels, and the second one is with meshes. Yeah. I think it would be probably more interesting to explore the direct relationship between neural networks and three-dimensional modeling instead of doing the step in between with the CA. Because it would give you a more straightforward, you know, workflow between the two, and it would really bring out the relationship between the information and the 3D modeling.
Yeah, it looks like a shortcut in a way, the CA in this case, like to go to 3D directly, and you don't need to, in a way.
You don't need to, yeah. Yeah. Honestly, I think just from the, let's say, theoretical part, I think it's really an interesting and provocative project that is very promising. So I'm very much looking forward to see what's going to happen here. But so are all projects, by the way. Yeah, just to say that.
I mean, we're up to the very first question. Are you actually, do you have the right to plan something for the AI? The very first question would be, of course, if you can initiate a city or propose an architecture for machine.
So I think personally, I think this will be like my advice overall for this year. I think you guys are really like trying to approach something that is super challenging. Like there's not a lot of research that is being done there, so that's super exciting. Should be something that really fuels in a way your ambition and really drives in a way the project. I think there are many interesting like approaches. I think the most important part is like to make those successful is mostly this aspect of really trying to master as much as possible the strategies, the tools that you're working with. You have to be careful to be very systematic to really approach like specific in a way, which are the most important things of that concept, and really drill down and apply the correct tools for it. Yeah, because I think there are many interesting ideas, but they could fail easily if they're not properly structured and they're not systematically approached. Yeah, so in that sense, yeah, that will be my suggestion to overall the class. Yeah, you have to be very careful with this kind of processes, how you set up the processes, what's the end goal, to be very clear with those kind of intentions. I understand also that part of speculation or stuff, but I think also when it comes to speculation, there are certain tools that help augment speculation and certain tools that actually limit. So it's still up to you in a way to know which is the perfect tool actually to help you engage more with that kind of speculative idea. And I think also touching a bit also on the last group, also this kind of relation between machines and humans, like how do you collaborate with these machines that you're building right now, you know, with this kind of networks. I think that's very important and crucial.
Thank you. And I just, on the basis of what Daniel just said, I just also agree, of course, on knowing the tools that they're developing and start to really, like Matias said, starting to make these sort of sketches that are more analytical rather than design sketches, and that are really helpful in terms of communication with Manas and with in the next semester. Please be very proactive in asking him a lot of questions in terms of don't wait until somebody comes to you and give you a lecture. From now on, it's really taking this month that you have off, taking a very serious time in continuing the research and really starting to have already some sort of a focused problem at the start of the semester. because you really have the opportunity to work, to start now. The last 2 years, I think we were very speculative in approaching the problem. And I agree with Daniel that there's a time to be speculative about it, but now I think we have the option through the collaboration with the Computer and Michigan Robotics Science Institute to really work on more complex problems and how we would like to solve them, and don't think about too much how they will look like, because that actually should come out. That should be really carving out your sensitivities, how you streamline those protocols to come together, and what kind of results they produce is something that we cannot visualize yet. And I think that's actually an opportunity. And I wish for you, for this next month, that you start to realize how great this opportunity is, that you don't know how it will look like, and that it's not so, that it is important, of course, but it's more important to surprise yourself with what can be the potential outcome than just striving to create something for the 10th, or in this case, it wouldn't be the 10th time, but it would be definitely the 5th or 6th time, create something. Take the chance and pursue the chance to work in this realm, to be really to creating something unique that's rare. Please take it as a fun ride rather than too seriously, but seriously.
So I want to add that Sandra is a very, very busy woman, and that I'm not surprised that sometimes the memory of reviews starts to blur into each other. So my comment about the sketch of concept was done in another review today, but that's fine. These things happen. These things happen. Yeah. So I'm not surprised you probably don't know what that was about, but that's okay. It happens. I would like to thank all our reviewers, also the ones who are not present anymore. It's recorded. They can look it up if they want to. That I said thank you for joining us. But a big thank you to all students for their fantastic work and for everything you went through this semester. And I know it's not the easiest semester in the history of Taubman College. We all, distance and with video and stuff, but I hope you still could pull off a fantastic presentation. Okay, this was our last meeting for this semester. It's a long break, in my opinion, but you guys, if I can give you one recommendation, keep working on it. It's going to be worth to also work on this during the break, so that next semester when we start again with the thesis project, you're all fresh with the memories, know everything by heart, you can code in and out, yeah, and all of that. So keep doing this. I thank you very, very much for the amount of work you put this semester. We all know it's a challenge to go into uncharted territories, which we're doing with this work. So mistakes happen. That's normal in this kind of stage of a project. But I thank you for being persistent and holding on to it and pressing through. Yeah. And next semester we're gonna do fantastic projects. So I'm really, really looking forward to that. Thank you very much to everyone. Enjoy Thanksgiving, and yeah, see you soon. Okay.
Thank you, and good luck with your reviews.
Good luck with your reviews. And if you have questions in between, just let me know, okay? Don't hesitate to contact me. All right. Bye, guys.
Good luck, everyone.
Thank you, Daniel. Thank you, Sandra, for being here.
Bye, Daniel.
Bye.
Bye, guys.